Passive Transport by James Stevens
and Monroe Roush.
Passive transport requires no energy from the cell, which is why it's called passive.
Substances are moved in and out of the cell through the semi-permeable membrane, and they are moving down the concentration gradient.
The concentration gradient is the measurable difference between the concentration of solutes in one mixture versus another, in this case, inside and outside the cell.
All types of passive transport work to create an isotonic environment, or where there is an equal amount of solutes and solvents in and outside the cell. The cell membrane is made of a phospholipid bilayer.
The phospholipids are made of a hydrophilic head and a hydrophobic lipid tail. These tails face each other and the head faces outwards, creating a hydrophobic region inside the cell membrane.
The cell membrane is semi-permeable to small nonpolar molecules and ions. Other molecules and ions have to be transported through the membrane using transport proteins.
Diffusion is a type of passive transport. There are two types, simple and facilitated.
Simple diffusion is when the molecules freely flow in and out of the cell without any assistance.
Facilitated diffusion uses transport proteins to assist molecules and ions across the cell membrane. This could happen if the molecule is large or nonpolar.
However, facilitated diffusion is still passive transport because the molecules are moving down the concentration gradient.
There are three types of transport proteins: gateway, channel, and carrier.
Gateway proteins have a channel through the cell membrane that the cell can open and close. Different molecules bind to the protein's active site, which can open the membrane if they are the correct molecule.
Channel proteins simply create a channel big enough for small molecules to fit through.
Carrier proteins literally carry molecules in and out of the cell membrane.
Osmosis is basically the diffusion of water.
Water moves from a solution with a higher concentration to a solution with a lower solute concentration, working to even out the solute concentration or to an isotonic environment.